So today's topic is electric current and its effects. So we will go back to the topic now. So I told you before also. So first, before telling anything about electric current, we will see some components of electric current. One is wire, a battery, light bulb, resistors, switches. Uh, these are the important components of electric current. So I have told before only the battery. Batteries are used in many places. You might have seen it in clocks and remote controls and everything. So when you buy battery from shops, normally battery what you will get is like 1.5 volt, 1.3 volt, 1.2 volt and all. So if your remote, for example, if your remote control needs 6 volt supply to operate, then at that time we will need 4 batteries. That's why we are using 2 or 3 batteries for each and every of your use. Like 2 batteries, if you are connecting together, it will the voltage will get double. Like if I'm buying 2 batteries from shop, so if I'm buying 2 batteries of 1.5 volt, then if you are connecting it together, we'll get 6 volt. For to measure that, we use voltmeter. This you might have seen in some places. This voltmeter measures the voltage of anything. For example, I told you like 2 batteries when you join together, 2 batteries of 1.5 volt. If you join together and measure, you can see it's 3 volt. If I am putting 3 batteries of 1.5, it will be 4.5. If I am putting 4 and 5, it goes on like that. And like example, like if I buy another one more battery with 1.5 volt, then if I'm connecting that to the circuit and if you are measuring, you can see it's 4.5 volt. Similarly, according to your use, you can add more and more batteries. Or else what you can do is like one single battery only you can buy. Like you might have seen in big batteries and all in cars and other appliances. Maybe you can buy a battery of 11 volt or 12 volt or 20 volt or 30 volt, 100 volt and also are available. So now I will just go back to another application of batteries. So again, batteries you can add parallel series. Any parallel series connections will be learning later in higher classes. So we will go to the connection first. So any basic circuit, if you have a light and you want to switch the light on, basic thing you require is a wire and a power source. If you have a power source, batteries are like as I told 1.5, 2 volt, 3 volt, and all small batteries come. So if it's like a big appliance like air conditioners or refrigerators and all, use power supply directly from the line. But if it's a small, for example, here it's a bulb. To operate or switch on a bulb, you don't require like high power or anything. You can use a very small battery and you can just connect the battery to bulb. It will be on. So this also you can use simple. This is the most simple circuit: a battery, light, and connected to wire. The important point here is like it depends on the battery's power, the light, the brightness of the light, and you can here what you can see is the flow of electricity. This is the most important thing that you are studying in this chapter is the flow of electric current. You can see the flow of electric current from positive to negative. You can see the speed here. If the electric current speed, if you want to reduce, like if the voltage is less, means like the flow will be slower, and you can see the increase and decrease in the brightness of light. Normally, if we are just showing here the brightness of light, but if the power is too big, no, it will blow off actually. Like if you are at this voltage also, the light is on. If you are giving like 120 volt at a time, suddenly a bulb will blow off. Any electrical instrument, it will have a power requirement or voltage specification you will see in the back of the electric appliances. If you give more power or more voltage than that, it will blow up. For that use, what you can do is like if I buy a battery, anyways, I can't do anything about the battery. The line voltage also, if you're considering from home, if you're getting 230 volt of supply, you can't do anything about that. So what you can do is like to protect your instrument, we use another thing called resistor. This is also one of the very deep subject, resistors. I'll give you like a small example of a resistor. Like to understand the resistor, just imagine some water is flowing through a pipe. So at the other end, you can use a tape and like you can increase the speed of the water. Like if you want more water, you will increase, like you will rotate it to the other end where you will get more water. But if you don't want so much water, if you want it in a very small amount or something, you will reduce the speed and you will, similar to that, if you want more current, you can reduce the resistor value. If you ready, you can see here resistance value, you can see as 10 ohms here. If you reduce the resistance, the current will increase. If you increase the resistance, current will now in any circuit you will find this also. You won't find a circuit without resistor, because that is basically for protecting your appliance. So here I will connect a resistor also to this circuit. Now before, what I was doing is like I was just I'll set another example for your better understanding. And this is the circuit without the resistance or resistor. Here also bulb is blowing, but I have to adjust the battery. I have to adjust the battery and reduce and increase it here, but I don't have to touch the battery. I can use the resistor and increase and decrease the brightness of the bulb. So battery, it's like a battery change every time. If you buy a battery of 1.5 volt, if you buy a battery of 10 volt, it will remain as 10 volt. But what we can do is like here, I'm just adjusting the battery, but then it's not possible in our real life. What we can just actually is the resistor. Resistor's value we can increase and decrease. Like the regulators and the fan and everything uses this principle. It will adjust the resistance so that you can increase or decrease the speed. So this is the basic difference in a circuit with resistance and with. And if anyone is saying, I mean, like another thing is like switches. If you want to switch on and switch off the light, now here what you can do it, like you can just delete the battery, but that is not possible again. So what we can do is like you can use another thing called switches. Switches means like you can connect it between the power source and the battery, I mean, and the light. So now I'm connecting a switch here to this circuit. Now you see switch is open, lights are not open. Switch is on. Always remember one thing. For current to flow, it should be a closed circuit. The current will not flow in an open circuit. Understand it well. Current won't flow in an open circuit. Current should be a closed circuit. So when you basically switch on the light, the circuit is getting closed. I will increase the resistance little, reduce the resistance little, because to see the light brightness. So now you can see lights are on. Now you can see resistance. Now you can see battery. Now you can see switch. So this is the basic circuit: a switch, a resistor, and a battery connected with wires to whatever. It can be bulb. It can be any other appliance. Depending on the appliance, we have to increase. Change the batteries, or like you can add the resistor. And one more thing I'll introduce here is fuse. This is also very important. This you might have seen in some circuits at your home or at some instruments and all. Fuse is also something something to protect your instrument only. Let's say like fuse, when you click the fuse, you can see here 4 ampere. This is the rating of the source. Like, let's say just one example, like if there is a light which requires only 3 amperes of light, I mean 3 amperes of current. So we'll connect a fuse of 4 amperes, because 3 amperes it's okay. Suddenly if they're like 5 ampere, 10 ampere, you can see during lighting and all, so many instruments and all blowing up. Similar to that, suddenly current is not stable always. It's always changing. So any small variations, any short circuits and all, suddenly can increase or reduce the current. So it will damage our, just imagine damaging air conditioners, refrigerators, you know how expensive it is. So to protect all that, we'll use fuse. So in the fuse, if it's mentioned 4 ampere, if passing through that, which is more than 4 ampere, the fuse will blow off. We'll just connect a fuse in this circuit and just understand the concept. Now I will switch on this circuit again, and now what I will do is like I will switch it on. I mean switch off the switch, and I will connect a fuse, this fuse to this circuit. Now there is a fuse. Now I will switch on. The current is passing through the fuse. There is no issues because as the fuse we put is 4 ampere. Now suddenly, just imagine my current I am increasing from the current I am increasing. I have to increase the battery a little. Like suddenly, battery current increase means like you can see here, the fuse is blown. Now there is no passage of electricity. Your light is safe, but fuse is blown. Now I will show you that one more time. I'll add a new fuse, and I reduce the current a little for the start. Now you see it's flowing, no issues at all. Now suddenly, because of some radiation, some short circuit, and suddenly and current gets increased and the fuse has blown out. So this is another very important thing in the circuit and in the appliances. We'll see it's a fuse. And in the home and all, with the fuse, what you can see is like you see the board, you will see these MCBs. What this do is the similar thing what a fuse is doing. Like all your appliances, main appliances will be connected to this directly, so that if any current which is more than the requirement, if it's passing through it, suddenly this will go off. We might have seen so many times, we might have did this, like going to the board and switching it off because suddenly uh, current is gone, and then you have to see because any short circuit and all, this will blow up to protect your instruments or appliance, because appliances are very expensive and fuse, it's very cheap. So to protect the appliance, we use this fuse. Now again, going, I told you, if it's an open, current will not pass through an open circuit, so no lights will be on. Anything won't work. Current won't work in an open circuit. To close the circuit, we use wire, because wire is a good conductor. Wire, inside that you will see copper wire and so it will conduct. Now we learn about conductors and non-conductors. So I said wires will conduct. So normally metals are very good conductors of electricity. Just I'll give you one or two examples, like paper clip. You know a paper clip. Now I'm just connecting a paper to circuit. You see current is flowing because paper clip is a good conductor of electricity. It allows the current to pass through it. And instead of paper clip, I'm using a coin. You know coin. No, coin is also a metal. I'm just connecting the coin to this, and still the current is passing. Coin is a good conductor. Now I will use another thing called eraser. You know eraser. So just connecting the eraser here, and you see current is not passing. So what you have to understand is eraser is not a conductor of electricity. It is called insulators. So things which can't conduct electricity are termed as insulators, and which conducts electricity is termed as insulator, conductor. And you will just see one more thing for pencil also. We'll just connect the pencil to this, and we'll see pencil is a conductor or insulator. See, the current is passing through pencil. It means like pencil is a good conductor of electricity. You know, pencil is made of lead. Lead is a metal, so it can pass the electricity. So pencil, be very careful when you're putting pencil and all inside your socket, because pencil is a conductor of electricity. So be very careful. So the main thing what you have learned today is a basic circuit, the components in the basic circuit, and conductors and non-conductors of electricity. So these are the most important topic. And one more thing is like I will just tell you about heating and magnetic effect also. In detailed class, I'll be giving next class. So heating effect is any metal, when you pass electricity through it will start heating. One of the examples is like iron work. Another example is water heaters and all. What it does is like when current is passing, the metal gets heated, and ironing and all. You know how hot is iron work. And another thing is like magnetic effect of electric current. When a metal pass through, when a current is passed through a metal, it behaves as a magnet. I will tell you that in detail with the experiment in the next session. Thank you for joining this session. Anyone have any doubt, you can ask now. Is it clear for everyone?
Yes.
And I will give you this link also. So what you can do is like you can go to this link, and you can connect different, you can change the values. You can increase and decrease the battery resistance and other things, and see how the circuit is behaving. I will give you this link also. So is it very clear for everyone? Just say Manha, is it clear? Is it clear,
Yes.
and
Yes.
Yeah.
Yes.
clear, no? So I will stop the session for now. I have to give another session to another class now. So just we'll send you this video also very shortly, WhatsApp and me WhatsApp. So just see, go through that, and if you have any doubt, note it down and send me the doubts. We will clear in the next class, or like I will do something in between if I can come online. Okay. So thank you very much for joining. Thank you.